Gigabyte.
The gigabyte is a multiple of the unit byte for digital information. The prefix giga means 109 in the International System of Units, SI, therefore 1 gigabyte is 1 billion bytes. The unit symbol for the gigabyte is GB. This definition is used in all contexts of science, engineering, business, and many areas of computing. However, historically, the term has also been used in some fields of computer science and information technology to denote the gigabyte, or 1,073,741,824, 10,243 or 230, bytes. For instance, the memory standards of JEDEC, a semiconductor trade and engineering society, define memory sizes in this way. To eliminate the ambiguity, the International Electrotechnical Commission has implemented the binary prefixes, a standard of multiplier prefixes for quantities expressed in binary multiples. The standard is endorsed by all standards organizations, including the IEEE, the International Committee for Weights and Measures, CIPM, and the U.S. National Institute of Standards and Technology, NIST, but the binary prefixes have seen limited usage. The JEDEC Industry Consortium continues to permit the IEEE 100 nomenclature of using the metric prefixes kilo, mega and giga in their binary interpretation for memory manufacturing designations, but have endorsed the binary prefixes.
Definition.
The term gigabyte is commonly used to mean either 10,003 bytes or 10,243 bytes. This originated as compromise technical jargon for the byte multiples that needed to be expressed by the powers of 2 but lacked a convenient name. American Samoa, 1024, 210, approximates 1,103, roughly corresponding SI multiples. It was used for binary multiples as well. In 1998 the International Electrotechnical Commission, IEC, published standards for binary prefixes and requiring the use of gigabyte to strictly denote 10,003 bytes and gigabyte to denote 10,243 bytes. By the end of 2007, the IEC standard had been adopted by the IEEE, EU, and NIST, and in 2009 they were incorporated in the International System of Quantities. Nevertheless, the term gigabyte continues to be widely used with the following two different meanings.
Base 10 definition.
1 gigabyte equals 1 billion bytes, equals 10,003 bytes equals 109 B, is the definition recommended by the International System of Units, SI, and the International Electrotechnical Commission, IEC. This definition is used in networking contexts and most storage media, particularly hard drives, flash-based storage, and DVDs, and is also consistent with the other uses of the SI prefix in computing, such as CPU clock speeds or measures of performance. The Mac OS X file manager from version 10.6 and higher is a notable example of this usage in software. Since Snow Leopard, file sizes are reported in decimal units.
Base 2 definition.
1 GB equals 1,073,741,824 bytes, equals 10,243 bytes equals 230 B, is the definition used by Microsoft Windows in reference to computer memory, for example, RAM. This definition is synonymous with the unambiguous IEC standard name gigabyte.
Consumer confusion.
Since the early 2000s, disk drive manufacturers based most consumer hard drive capacities in certain sized classes measured in decimal gigabytes. The exact capacity of a given drive model is close to the class designation. Most manufacturers of hard disk drives and flash memory disk devices define 1 gigabyte as 1 billion bytes, which is displayed on the packaging. Some operating systems now express hard drive capacity or file size using decimal multipliers, integer powers of 1000, while others, such as Microsoft Windows, still report size in gigabytes by dividing the total capacity in bytes by 1,073,741,824, 230 bytes equals 1 gigabyte, while still reporting the result with the symbol GB. This discrepancy causes confusion, as a disk with an advertised capacity of, for example, 400 gigabytes, meaning 400 billion bytes, might be reported by the operating system as 372 gigabytes, meaning 372 GB. Other software, like Mac OS X 10.6 and some components of the Linux kernel measure in decimal units. The JEDEC memory standards use the IEEE 100 nomenclatures, which define a gigabyte as 1,073,741,824 bytes, or 230 bytes. The difference between units based on decimal and binary prefixes increases as a semi-logarithmic, linear log, function. For example, the decimal kilobyte value is nearly 98% of the kilobyte, a megabyte is under 96% of a megabyte, and a gigabyte is just over 93% of a gigabyte value. This means that a 300 gigabytes, 279 GB, hard disk might be indicated variously as 300 gigabytes, 279 gigabytes or 279 GB, depending on the operating system. As storage sizes increase and larger units are used, these differences become even more pronounced. Some legal challenges have been waged over this confusion, such as a suit against Western Digital. Western Digital settled the challenge and added explicit disclaimers to products that the usable capacity may differ from the advertised capacity. Because of its physical design, the capacity of modern computer random access memory devices, such as DIMM modules, is always a multiple of a power of 1024. It is thus convenient to use prefixes denoting powers of 1024, known as binary prefixes, in describing them. For example, a memory capacity of 1,073,741,824 bytes is conveniently expressed as 1 GB rather than as 1.074 gigabytes. The former specification is, however, almost always quoted as 1 gigabyte when applied to random access memory. Software allocates memory in varying degrees of granularity as needed to fulfill data structure requirements, and binary multiples are usually not required. Other computer measurements, like storage hardware size, data transfer rates, clock speeds, operations per second, etc., do not depend on an inherent base, and are usually presented in decimal units. For example, the manufacturer of a 300 GB hard drive is claiming a capacity of 300 billion bytes, not 300x10243, which would be 322,122,547,200.
Examples of gigabyte-sized storage.
1 hour of SD-TV video at 2.2 Mbps is approximately 1 GB. 7 minutes of HD-TV video at 19.39 Mbps is approximately 1 GB. 114 minutes of uncompressed CD-quality audio at 1.4 Mbps is approximately 1 GB. A DVD can hold about 4.7 GB. A dual-layered Blu-ray disc can hold about 50 GB.